last time we can discuss about the preparation method of alkanes, some preparation methods which we can discuss in the previous lectures. Now we can start with some another methods to prepare the alkane, clear. Now the title is that we can continue preparation of alkane. Now we can prepare the alkane by reduction of aldehyde and ketone. What is the method name? By reduction of aldehyde and ketones, clear. Suppose what is the general formula of aldehyde? It is RC double bond OH. What is the general formula of ketone? RC double bond R. If we can have aldehyde or ketone, we can reduce it with the help of two name reactions or with the help of two chemical reagents, clear. If any reaction have a particular name with the help with respect to scientist or with respect to anyone, then we can say that it is a name reaction. It is a name reaction. If we can reduce aldehyde or ketone, here we can take only and only ketone, but these reactions are possible in aldehyde also, clear. There are two methods to reduce the aldehyde and ketone into alkane. First one is Clementine reduction and second one is Wolff Kishner reduction. What is the name? Clementine reduction and Wolff Kishner reduction, clear. What is the reagent which we can use for the Clementine reduction? It is ZnHg and concentrated HCl. Remember that is acidic media. ZnHg and concentrated HCl in acidic media. What is the reagent for Wolff Kishner reaction? It is NH2, barabar. It is a basic, and now in this reaction we can use a solvent which is a glycol, clear. The conversion is same. If we can have aldehyde or ketone, we can carry out the Clementine reduction or Wolff Kishner reduction, we can get an alkane. What is the method? Here O is removed and 2 hydrogen is added. Suppose it is aldehyde like that, C double bond OH, then it is like that, RCH. Here we can attach 2 hydrogen. We can remove O and we can add 2 hydrogens. We can remove O and we can add 2 hydrogens. So it is a 2 reduction method to get the alkane from aldehyde and ketone, which is very famous, Clementine reduction and Wolff Kishner reduction, clear. We can remove the O and we can add 2 hydrogens to this carbonyl carbon, clear. First of all, we can discuss about some important points of Clementine reduction. RC double bond OH, we can have aldehyde, any aldehyde. We can carry out the reduction with ZnHg in the presence of concentrated HCl. It supplies the 4 hydrogen. It supplies the 4 hydrogen to give RCH3 plus H2O. It is a byproduct H2O. RCH તો હતો જ, અહીંયા બે હાઇડ્રોજન આપણે કનેક્ટ કરેલા, ટોટલ શું થઈ ગયું? RCH3. It is alkane. Clear? It is like that. RCH and H2, RCH3. Clear? Suppose if we can have a ketone, RC double bond OR, and we can carry out the same reagent, ZnHg concentrated HCl, it can supply 4 hydrogen and we can have RCH2R plus H2O. અહીંયાથી ઓક્સિજન રિમૂવ થયો અને અહીંયા બે હાઇડ્રોજન આપણે એડ કર્યા, ક્લિયર. નેક્સ્ટ, now we can take the some particular examples. CH3 C double bond OH, it is aldehyde. CH3 C double bond OH, carry out the Clementine reduction, it can supply 4 hydrogen. CH, BH અહીંયા કનેક્ટ થશે એટલે CH3 alkane and H2O, clear. આ એક H હતો અને અહીંયા બે H એડ થયા એટલે CH3. You can have a ketone, CH3 C double bond O CH3, same reduction, CH3 C 2H and CH3, CH2 CH3 CH2 CH3 plus H2O. Suppose if we can have a compound like that, cyclohexane ring C double bond O and CH3, it is a ketone. We can carry out the reduction and we can get the compound like that. It is reduced to alkane, H and H. H no લખો તો પણ કોઈ ફરક પડે નહીં. Now the main question is that suppose if we can have a molecule like that, 5 member cyclic ring, here OH which is a basic group, yes or no, here a ketone, there is no doubt if we can carry out the Clementine reduction, this is reduced to this. Now the question is that it is reduced or not. જો એક પ્રોડક્ટ તો આ મળવાની ફાઇનલ જ છે કે આ તો રિડ્યુસ થવાનો જ છે. Now the question is that this OH is reduced or not. We can get the product like that or like that. Now the question is that this OH is reduced or not. Now we can study some concepts regarding to this point of view. Clear? So it is very simple method to get the alkane. Now we can discuss about this. Now we can discuss the product of this molecule. 5-member ring OH and C double bond O, CS3. Clear? It is a basic group. Now oxygen have a 2 lone pair. We know that the reaction is carried out in the presence of HCl, means acidic media. HCl means H plus and Cl minus. This electron pair abstract the H plus and remove as a H2O, and this Cl minus is substituted in the presence in the place of OH, and we can get the Cl. This is a nucleophilic substitution reaction. This is reduced to hydrocarbon H and these parts are substituted with the help of nucleophile Cl minus. What is a nucleophile electrophile, which you can discuss in the next lectures. Clear? So remember that if we can have a basic group, then the reaction is carried out in the acidic media. This basic group is reduced, but not only reduced, it can give a nucleophilic substitution reaction. Therefore, here substitution of chlorine is carried out. It is the main point of Clementine reduction. Clear? Suppose if you can have a compound like that is C double bond O, 6-member ring OH. It is also a basic. What is the phenomena? It can abstract the H plus and remove as H2O. Now Cl minus is substituted here, so we can get जो आतो substitute थे जो यहाँ H and H એટલે લખવાની કોઈ જરૂર નથી ને અહીંયા શું H થઈ જાય Cl. It is a product. Clear? જો આવું ક્યાંય હોય તો આવું કરવાનું. Next CS3 C double bond O, CS2 C double bond O and OH. અહીંયા પણ આવું થશે C double bond and OH. It is a carboxylic acid. It is an acidic group. તો અહીંયા શું થશે તો આ તો reduce થશે because of a ketone CS2. But આ reduce થશે નહીં. Basic group હોય તો જે reduce થાય, acidic group reduce થશે નહીં. It is remains C double OH. Clear? Next, it is also some characteristic C double bond O and NO2. If we can have if we can carry out a Clementine reduction, then NO2 is also reduced to NH2. Here H and H we cannot write. Clear? This is some important points regarding to the Wolff Clementine reduction, which we can note down. Clear? Here nucleophilic substitution reaction થાય, but એના માટે ગ્રુપ બેઝિક હોવું જોઈએ. આ પણ બેઝિક છે. એસિડિક ગ્રુપમાં પોસિબલ બને નહીં એક આ ખાસ કે NO2 નું NH2 માં કન્વર્ઝન કરી શકાય. ક્લિયર? સો now we can discuss the second method, which is Wolff Kishner reduction. Now we can study the Wolff Kishner reduction. Suppose if we can have aldehyde or ketone RC double bond OH and RC double bond OR, the reagent for Wolff Kishner reduction is hydrogen NH2 NH2. Clear? Now first of all we can get the hydrazone. What do you mean by hydrazone? We can remove O with 2H, means minus H2O, and this is connected to direct here double bond N NH2. Clear? It is a hydrazone. It is reduced in the presence of basic media KOH or ethylene sodium ethanoate C2H5ONA up to 453 Kelvin. We can get the RCH2H. હવે અહીંયા બે hydrogen connect થઈ જશે. Clear? What is the exact reaction products which we can discuss in this next? It is also a hydrazone. C double bond N NH2, which you can study in detail in next chapters. If we can have a CS3 C double bond OH aldehyde and hydrogen NH2 NH2 in the presence of KH or C2H5ONA, first of all we can remove the H2O like that. અહીંયાથી આપણે ઓક્સિજનને રિમૂવ કરશું અને NH2 NH2 માંથી H2 એટલે રિમૂવ શું થયું H2O. હવે CH3CH remains as it is. This H2 is directly attached to here, therefore CH3HCH2. હવે બચ્યું શું તો કે અહીંયા પણ એક N, અહીંયા પણ એક N. It is released as a N2. What is the products? H2O plus N2 plus alkane. Clear? It is also written like that, CH3CH3. Next, ketone CH3 C double bond O CH3 plus NH2 NH2. We can reduce with the help of NH2 NH2 in the presence of KH or C2H5ONA. We can get H2O N2 because this part first removes as H2O. These two hydrogens are directly connected here. CH3 CH3 CH2 and remaining N are removes as N2. Clear? Next, first of all, if we can have examples like that, 6-member ring C double bond O CH3, we can reduce with the help of NH2 NH2 OH minus. It is a glycol, which is nothing but a solvent. Yes, it is used in the presence of moist, means in the presence of H2O. Wolff Kishner reduction is carried out in the presence of solvent glycol or moist H2O. Clear? So it can reduce this into this. Clear? It is very simple. Now if we can have the similar case which you can discuss in a Clementine, C double bond O and OH, it is a basic group. Now it is clear, it is reduced. OH is reduced or not with the help of NH2 NH2 or in the presence of CoH? Answer is not. Why? Because it is basic and it is also basic. આપણે જોયું તો ક્લેમેન્સનમાં એસિડિક એસિડિકમાં ઇફેક્ટ નથી થતી, તો સેમ અહીંયા બેઝિકમાં ઇફેક્ટ નહીં થાય, આ એઝ ઇટ ઇઝ રહેશે, આ રિડ્યુસ થશે. સેમ આ રિડ્યુસ થઈ શકશે, આ રિડ્યુસ થઈ શકશે નહીં. જો યુ કેન ચેક ઇટ. નાઉ ઇન Clementine we can discuss the nitro into NH2. Here this reagent cannot reduce nitro into NH2, it is remain same, it can reduce only and only aldehydes and ketone. Clear? So it is a very important reduction patterns to give the alkane from aldehyde and ketone, which is Wolff Kishner reduction and Clementine reduction. Now we can discuss the next methods. Now the next method to preparation of alcohol is by reduction of alcohol, aldehyde, ketones, carboxylic acid or its derivative, means carboxylic acid's derivative. Clear? We can get the alkane from the reduction of alcohol, aldehyde, ketones, carboxylic acid and derivatives of carboxylic acid. The reagent for this purpose we can use is a red phosphorus and HI. Red phosphorus in the presence HI in the presence of red phosphorus. It is a very strong reducing agent. Clear? Which can reduce alcohol, aldehyde, ketone, carboxylic acid and its derivative. First of all, we can remember some sequence. If we can have acid, it can reduce to aldehyde and ketone with the help of 2 hydrogen. Clear? If we can have aldehyde and ketone, it is reduced to alcohol with the help of 2 hydrogen. And we can have alcohol, then it is reduced to alkane with the help of 2 hydrogen. Means if we can reduce alcohol to alkane, we can have required 2 hydrogen. If we can reduce aldehyde to alkane, we can require 4 hydrogens because 2 and 2 4. And if we can require if we can convert acid to alkane direct, we can require 2, 4 and 6 hydrogens. Clear? The question is that here the reduction purpose only and only hydrogen is requirement. So why we can use the red phosphorus? Red phosphorus is used in the purpose in every reaction iodine is liberated. In every reaction iodine is liberated. This iodine is give the reversible reaction. Iodine જે હમણાં આપણે રિએક્શન ભણશું તો આયોડિન હશે એમ રિવર્સિબલ રિએક્શન આપશે. રિવર્સિબલ રિએક્શન આયોડિન ન આપે અને ફક્ત આપણે પ્રોડક્ટ મેળવી શકીએ એટલા માટે રેડ ફોસ્ફરસ રાખ્યું. ફોસ્ફરસ આયોડિન સાથે રિએક્શન આપી રિએક્ટ કરી અને ડાયરેક્ટ PI3 માં કન્વર્ટ કરી દેશે, જેથી કરી અને રિએક્શન રિવર્સિબલ રહે નહીં. અધરવાઇઝ રિએક્શન ઇઝ રિવર્સિબલ. સો વાય વી કેન યુઝ હિયર a red phosphorus because we can generate the I2 and this I2 is also give the reversible reaction. Therefore if we can have a I2, then reaction carried out in the forward backward direction and the product is less. We can have only and only forward reaction, therefore we can use red phosphorus. Red phosphorus is react with I2 to convert into PI3 and now iodine is not reactive. Clear? If we can have alcohol, aldehyde, ketone, carboxylic acid and its derivative, we can use the same reagent. Red phosphorus 243 243 243 બરાબર. મિનિમમ મતલબ કે ટેમ્પરેચરની રિક્વાયરમેન્ટ પડે. કાર્બોક્સિલિક એસિડ અને ઇટ્સ ડેરિવેટિવમાં 473 એટલે કે થોડાક હાયર ટેમ્પરેચરની રિક્વાયરમેન્ટ પડશે. ક્લિયર? ફોર ધ રિડક્શન ઓફ આલ્કોહોલ, aldehyde, ketone we can use 423 and for the reduction of acetic acid and carboxylic acid and its derivative we can use 473 Kelvin temperature. Clear? First of all you can have CH3OH methyl alcohol. Alcohol માંથી conversion કરવા માટે how many moles of hydrogen is required? 2. Therefore you can use 2HI. It can give CH4 plus H2O plus I2. CH4 plus H2O plus I2. Clear? Aldehyde માંથી જો આપણે conversion alkane માં કરવું હોય તો we can require 4 hydrogen. Therefore you can use 4 times HI. Gives ethane plus H2O plus 2I2. It is very simple. If we can have a ketone, we can also require 4 hydrogen. Clear? CH3, CH2, CH3, C double bond O reduced to CH2. Clear? Same. Next H2 and 2I2, carboxylic acid 6 hydrogen. Because carboxylic acid માંથી જો તમારે alkane જોતો હોય તો 6 hydrogen ની requirement પડે. CH3 plus 2H2O plus 3I2 same વસ્તુ. CH3 C double bond OCl acid chloride છે અને reduction માટે પણ 6 hydrogen ની requirement પડે. બરાબર? We can get ethane plus H2O plus HCl and 3I2. So it is a very simple method to get the alkane by reduction of alcohol, aldehyde, ketone, carboxylic acid and derivatives of carboxylic acid. The reagent is Hi in the presence of red phosphorus at a higher temperature. We can get the alkane like that. Clear? Now we can discuss some other methods. Now we can study the two important methods. First one is by Franklin reaction. Second one is hydroboration of alkenes. What is the Franklin reaction? If we can have an alkyl halide Rx, we can give the treatment with zinc metal. In the presence of ether, we can get RR and ZnX2. RR and ZnX2. It is removed as ZnX2 and these two are coupled to each other. Suppose if we can have one example, ethyl iodide C2H5I plus Zn plus C2H5I. Now I and Zn combine to give Zni2 zinc iodide and we can get the C2H5 combined, which is butane. Normally it is CH3 CH2 CH2 CH3. This part and these parts are combined to each other or coupled to each other. Clear? It is very important reaction from the point of view of preparation of alkyl. Franklin reaction. In the presence of ether, zinc gives the reaction of alkyl halide to alkane. Clear? Next one is hydroboration of alkenes, which we can discuss very deeply in the alkenes, but here we can have some important points. If we can have alkene like that RCH triple bond CH2, we can give the reaction with diborane B2H6 in the presence of diglyme. Diglyme is a solvent. It gives a trialkyl borane RCH and this is a valency. We can remove the double bond and we can create a valency, and here we can add H 3 times Nb. It is known as trialkyl borane. It is converted into alkane in the presence of acid or CH3COOH RCH2 CH3 3 times. Clear? So it is the second method. Yes. આની કઈ ચિંતા કરવાની અત્યારે જરૂર નથી. We can discuss very deeply in the properties of alkene. Clear? So this is the preparation methods of alkanes.